Okay, so we did solve our triangles, and other than my big error or whatever, we kind of got through with our law of sines, law of cosines, sum of all the angles in a triangle equal 180. And that's what we're going to be working with again today, except for there is an issue. And the issue comes from sine, and that is because sine is positive in both the first and second quadrant. And your calculator will only give a first quadrant answer. And so it's our job to figure out, in certain instances, if there is a potential for a second triangle to be drawn with the same given information. And we'll do our best to kind of draw this out so you can see what the issue is. Do you remember back in geometry, side, angle, side, 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 angle, side, angle? Okay. And then you were told that this one, which I won't say, I'll just write, doesn't exist. And it's not that it doesn't exist. It's not that we can draw or can't draw a triangle with this given information. It's just that it is what it says. It makes our life a little bit difficult because when we are given this information, that is the only time that there is a potential for two different triangles for that given set of information. And I say potential. So this is what it looks like, and it's a little bit hard to draw, so kind of watch my drawing and I'll show you where it goes. I could be given this information, okay, where I'm given this angle here. I'm given the side opposite the angle, and I'm given a side adjacent to the angle. So the information that I know is an angle measure, an opposite side, and an adjacent side. And I probably should spell those all out, so I will. Opposite, which I will abbreviate, and adjacent, and the angle. So given angle. This is an angle side scenario. I'm given an angle, an opposite side, and an adjacent side, as opposed to a side angle side scenario, which would look like this. I'm given a side, I'm given another side, and I'm given an angle. That's a side angle side. Do you see the difference between the two of them? This is a side angle side scenario. This is a this scenario. And it has to do with the location of the angle with respect to the sides that are given, okay? And again, this one is exactly as it says, because this information doesn't necessarily give us a unique triangle. And that is because not knowing what this top angle is, I could draw the same information for the triangle without changing the angle, the adjacent, only changing the direction of that top angle. These two measures are the same. Do you see what I'm talking about? I have, with the same information, two separate triangles. I have this one that has an obtuse angle in it, where these two things are the same. The adjacent doesn't change, this angle doesn't change. And then I have this one on the outside where it has an obtuse angle up on the top. Potentially it might not even have that, okay? So those are two different triangles with the same given information, all right? Our job is to figure out if this can happen, and it takes some specific things to occur. First of all, number one, I don't need to worry about it or look at anything else if it is not this, okay? If it is this given information, Then I have to check for two solutions. And the second thing I need to look at is the opposite side compared to the adjacent side. The opposite side has to be less than the adjacent side in measure. It's got to be shorter in length, and you can see that in our picture. Our adjacent side is longer than our opposite side. That's what allows the movement to sort of swing to one position to the other, okay? So the second thing that has to happen is the opposite side has to be less than the adjacent side. And the third and final clinching factor is that the opposite side needs to be greater than the adjacent side times the sine of the angle. So I have to look at all of those things, the sine of the angle. Every single one of these things has to be true. And again, I'm very vague on this next statement too, to give us the potential for a second triangle. Okay? If all of these things aren't true, there is no chance that you'll have a second triangle. If all of these things are true, there is potential for a second triangle. That fits the original description, okay? Because this is the only one that is a troublemaker when I'm given this information, on today's work, you're not going to get any other information other than an angle side-side scenario, because that's the only time that we worry. And I want to go through, okay, how do we tell if there are two triangles for the given situation, or how do we tell if there is no triangle for the given situation, and how do we look to see if there is truly only one triangle for the given situation, okay? So we're going to start the same way that we did I feel like it was last week, but Monday, right? It was just 2 days ago. We're going to draw our triangle. I draw the same triangle every time. It's just a dummy triangle. I label it the same way, Q, R, P. I'm given 96 degrees for angle P. I'm given side P as 24. I'm given side R as 5. And now I have to check the three things. Is this an angle side-side situation? Yes. So the angle side-side part checks. And remember, I said to you, today all of yours are going to be angle side-sides, okay? Then I check the opposite side compared to the adjacent side. Is the opposite side less than the adjacent side? No. This fails, and therefore, there is definitely not two triangles here. There is 1 or 0 triangles for this given scenario. So I will start to solve. If there are 0, it will be telling very quickly. I mean, we'll know within our first couple moves, because it'll give me something like a domain error, it's not possible. And that happens when you have a big angle across from a small side, or vice versa, okay? So I can do law of sines here. The sine of 96 over the opposite side is equal to the sine of r over 5, and I'm going to go ahead and solve for r. Again, if this isn't going to work, I'm going to get a domain error or something funky when I plug this in the calculator. And again, I need your assistance because I can't do this without a calculator, or with the calculator that I have. So I want somebody to give me roughly what r is. It would just be 5 times sine of 96 divided by 24.
12.
So you got 12 for the degrees for r. Rounding up. Okay, 12 degrees for r. Great. We got an answer? Good. Then that means we can proceed to find the rest of the answers. I always take a look at my picture and make sure that it makes sense to what we have. The small angle across from the small side, that's very reasonable. The big angle across from the big side, also very reasonable. I need to go ahead and find the other angle, and that's Q. And Q is 180 minus 96 minus 12, or 72. Great. So I know that angle here is 72 degrees. And now the last thing I need to do is find side Q, because that's the only other side that's missing. I have R, I have P, I don't have side Q, and so we'll just go back in and do what we did earlier. I'll use the sine of 96 over 24, and then do the sine of 72 over side Q, and work my way through and solve, again, setting up my proportion, plugging it in, 24 times the sine of 72, make sure you close your parenthesis, divided by the sine of 96, and again, I'll wait for some answers. Give her a second.
I got 22.9.
Did anybody else get 22.9-ish? Okay. And as far as your rounding goes, I don't care too much if you go to the 10th place, whatever. I don't check it too much. Do not tell your science teachers about that, because I know they get real precise if you're in machining. So this is 22.9 centimeters. I got these all, I was able to find all of the missing parts. Therefore, this had one solution. Okay? So I know that the number of possible triangles here is only one, and that's because I was able to find them all. So let's see what an the ASS can really be. Okay? So I'm going to go through the same process. A, B, C. A, B, and C. Angle A is 42. Side C is 30. Side A is 24. Do I again have an angle side-side scenario? And yes, again, I told you, all of them will be today. It's flipped a little bit, but it still has an angle, an opposite side, adjacent side. Okay, so as far as the ASS is concerned, that works. So 42 across here, this is my opposite side. The remaining one is the adjacent. Is the opposite side less than the adjacent side? Yes, check. That also worked. All right, so I will go down and find the next one. Is the opposite side greater than the adjacent side times the sine of the angle? And I'll have you guys check that again. What do I get for this? $20.07, and yes, this also checks. Because all three of them checked, there is a potential for 2 or 0. Okay? So 2 or 0, and I figure out the 0 if when I start to solve, it doesn't work. Or if I recognize something funky going on with the information that's given, I don't even have to jump in and start to solve. But I'm going to start to solve, and I'm going to start to solve under the assumption that I could potentially have two solutions. So I need to find angle B for the first solution and angle B for the second solution. I better put angles in front of those. I need to find those. I need to find angle C for the first solution and angle C for the second solution. And then I'm also missing side B. The troublemaker will always be the first angle that you are able to solve for. That is always the one that will give us a first quadrant answer, even though we have the potential for a second quadrant answer. because both of them are going to have the same ratio. They're both positive. So what's the first thing that I can solve for in this picture?
Angle C.
Angle C. This is my troublemaker. Angle C is the trouble, and I'm going to have to deal with it. So I'm going to find angle C. The sine of 42 over 24 is equal to the sine of C over 30. And again, you are going to get a first quadrant answer. I'm going to let you guys, again, do that work and tell me what it is, and then we'll deal with it. 56.8. 56.8 degrees. Okay? If this were a second quadrant or an obtuse angle, its counterpart would be 180 minus 56.8. That would be 56.8 in the first quadrant, 56.8 away from the axis in the second quadrant, and so it's 180 minus 56.8. You said it's what?
123.2.
123.2. So those are my starts for my two potential. This, again, the first angle I can find is the troublemaker. It is the only thing that I'm going to have to mess too much with. It's going to give me my first quadrant answer. I have to find my second quadrant answer. Now, once I have those two figured out, I can finish the rest of the solving. So what is angle B if angle C is 56.8 degrees? We can do 180 minus 42 minus 56.8, and what do we get? 81.2. And if B is in fact 81.2, then what is side B? So I will go down here, I'll do the sine of 42 over 24 equals the sine of 81.2 over side B. That'll give me my first solution, side B. And again, this is just a matter of plugging this stuff in. 35.4. Does anybody concur? Anybody agree?
Yeah.
Okay. Seems reasonable? Okay. If the first angle that we found was truly correct, it was an acute angle, that would make angle B end up being the biggest angle in the triangle at 81.2 degrees. Which means that it's going to be across from the biggest side, which is 35.4 degrees, and that looks pretty reasonable too. Biggest angle, biggest side, okay? If angle C is in fact an obtuse angle, which we don't know by plugging it in our calculator, so we have to assume that either one of these triangles could be true. If it is, then that's going to change the side of angle B. In fact, it is going to make angle B much smaller. 14.8, okay? If you want to use 15 degrees, I don't care when you're doing your work, that's fine. And now that angle B shrunk substantially, because angle C was truly the bigger one, side B will also shrink substantially. So I'll go back and I will find side B, but this time I will solve it with its new angle, 14.8. And again, I'll get a much smaller side. And the whole thing here is, this is the information that I'm given. And in the process of solving, I realized that this is not one unique triangle, because that side, I don't know that top angle, what it is. It could hinge around and be one of, or in this case, it's the B angle. That could be a big angle or a small angle. I am going to make sure that I cover all bases and solve for all of them. Okay? So what does side B end up being? 9.2. And again, hopefully that makes sense that it now, if angle C is the bigger one, and these are all ifs. If it's the case that angle C is actually an obtuse angle, the second quadrant angle, then that changes the size of angle B, and angle B will ultimately end up changing the size of sine. Okay, so that's what a two triangle situation looks like. But remember, it has to start with all of the stars aligning. All of these things have to be true. And then we can figure out where our problem is by the very first step. Okay? Very first step in the process. So my bubble around my answer becomes much bigger here because I have both of those situations that could be. All right. What does a no solution look like? Well, no solutions are sometimes obvious right out of the gates. And other times not so obvious. And we will along the way, or maybe we miss it, but along the way we'll figure out. And I'm going to go through both what you can expect to see here. So when I draw my triangle, BCA, again, I'll first check to see if it is going to be what we think it is. And that is angle B is 112 degrees, side B is 29, side A is 32, and yes, check, it is an angle side-side. Then I will check to see, is the opposite side, 29, less than 32? Check, yes it is. So then I'll check with the angle involved, is the opposite side more than the adjacent side times the sine of the angle? And again, when I plug that in, or when you guys plug that in, somebody can let me know if it passes here. What is it? 29.7, so it actually fails. So it fails there, meaning that I have 1 or 0 triangles. I know right now there are 0 triangles. And not just because I made up the problems that are on this paper, but anyone else know? Yeah, the biggest side has to have the biggest angle. Well, how do we know what the other angles are? We haven't solved for them yet. I don't know what they are, but I know what they can't be. They can't be 90 or bigger, because then this would add to be more than 180. So there's no angle that's going to be bigger than 112 in this picture, and therefore this has to be the biggest side, and it's not. Okay? So I know right now there are none. But then you might be thinking, well, I don't know if I'm going to remember to look for that, or if I'm going to be able to do that. Sometimes I just have to do the process. So fine, do the process. I need to find angle A, I need to find angle C, and I need to find side C if this has a solution. Okay? And so I'm always able to start with one thing, and for me today I can start with angle A. So I'll put the sine of 112 over 29 and set that equal to the sine of A over 32. And when I start to try to solve this, I'm going to end up with something here, when I do this process here, that is more than 1. Okay? In fact, what do we get? 1.02, blah, 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 blah. Okay. I don't know if there's more on there. If there's not, anyways, that's the sine of A. Can the sine ever be something more than 1? No, it can't reach 1 or pass 1 in our graph of sine unless we multiply by something in front, which we don't have going on here. So this will show up as a domain error if you start to solve it. The sine inverse of 1.02 will come out to domain error, which means that there's no such triangle, and that's how I can cross off the one solution. Okay? That's what that one looks like. Okay. Just a question from your input. It doesn't matter how you answer this. I'll take it either way. I want to do at least one more, and at least one more with two solutions. Do you want to see a one solution and a zero solution again, or do you think you guys feel okay with that? The only new one is the two solution. That's the one that's causing the issue. Okay, so we're going to slide on down to number 6. And we already know this is two solutions, but we're going to go through the whole process again. So I'm still going to draw my triangle. H, P, K. H is 62. Side H is 32. Side K is 34. And I go through that process. Yes, this is a side-side angle. And again, I'll tell you, all of them today will be side-side angles, so that's an automatic check, all right? Is the opposite side less than the adjacent side? Because this is my opposite, meaning opposite the angle. This is my adjacent, meaning the one that's next to the angle. So opposite and adjacent. And the next thing I check, oops, that is a check, is that opposite side greater than the adjacent side times the sine of 62 and 30. And so check again. Good. So check, check, check. That means that I have 0 or 2 solutions. So there still potentially could be 0 solutions. So what I do is I check the sides. There's nothing really telling here. 62 degrees. That could be the biggest angle in the triangle. It could also be the smallest angle in the triangle. Or it could be the middle in the triangle. And so nothing tells me here about whether it's 0. So I will do my setup. We've decided it could be 2. So I'm going to jump in acting like it is 2. I need P for the first, angle P. And then I need angle P for the potential second. And I need angle K for the first and angle K for the second. And the order that you put these in doesn't really matter. But I also need side P for the first, and I need side P for the second triangle. And so I'm going to figure out which one of those I can find first. And it looks to me like angle K is going to be my troublemaker. So I'll do my setup. The sine of 62 over 32 is equal to the sine of K over 34. And this is definitely going to give me a first quadrant answer. And I'll wait to hear from you what it is. And then I need to find the second quadrant answer. Okay? So what's the first quadrant answer when you do your plug, plug, plug? Anyone get an answer? 69.7. 69.7. Should we? Let's just call it 70 for ease of math right now. Okay. And a lot of times we forget, but it's really just taking, if this angle here is 70 degrees into the first quadrant, I want to go 70 degrees backwards into the second quadrant. And so that's just simply a second quadrant angle, 180 minus 70. That would give me 110 degrees. And if K is 70 degrees, then angle P will be a bigger angle. Sorry, if angle K is 70 degrees, angle P will be a bigger angle. So that's 180 minus 62 minus 70. The 62 will never change. It's a given. Okay? That's never going to change. What do we get?
48.
48. And if angle P is 48, then I can use that to find side P. Again, the given information never changes. So sine of P, which is 48, over side P. I can find my first quadrant value.
I got 30.
30, anybody agree?
Or, sorry, 27. I'm reading.
27, anybody agree? Okay, I got some nods there, so 27. This is meters, so I'll put my label on there. All right, again, if K is not a first quadrant answer, if K is in fact a second quadrant answer, which we have to figure out because our calculator can't tell us that, if K is the second quadrant answer, that's going to make P much smaller. And so my new P is 180. The 62 doesn't change because that's a given. That's not going to ever change. Minus the 110 that we figured out for our second quadrant answer. And what do we get here? 8 degrees. Okay. So big difference between 48 and 8. And even though 48 is still the smallest angle, 8 is the smallest angle. Because 48 changing to 8 if K is under 10, side P will be much smaller than 27. So my side P is going to change as a result of that potential change. So the sine of 62 won't change, over 32 won't change, but what if it is 8? What does P end up being? 5 meters. Great. Super duper. Okay. 5.52. 5.02. 5 point whatever. It depends on how you round it. That's where there's going to be a little bit of wiggle room here, you guys. So if you are not rounding, if you're keeping things exact in your calculator all the way through and only rounding towards the end, you will end up maybe with a little bit of a different answer. Just write down what you're using, and that's all I need to see, and I will be able to figure that out in my brain. You'll get a different answer if this was 69.7 or whatever, and you use that instead of 70. Again, all of those things are going to come into play. But that is what your assignment is today, dealing with that stuff. And so I think a good assignment for this is, let's just do, again, evens or odds. Okay, so again, we'll do evens or odds on this assignment. Evens or odds is fine. If you choose evens or odds, it doesn't matter which one you choose. On the assignment, you will have one of each scenario. One with no solutions, one with one solution, one with two solutions. So if you end up with 2 no solutions on the evens, one of them is wrong, okay? Expect one of each. If you find it right out of the gates, the 2 solution one, then it's smooth sailing from here on out.